Okay, so this one deals specifically with functions, section 1.4. Now the idea of a function, it's just a specific type of relation. Now a relation just compares two things. So a formula can be a function. Sorry, I keep walking away from the mic. A formula can be, or a function I should say, has two variables in it. Okay, and their relationship between each other has to follow a specific pattern. If each item from one set matches exactly one item from a different set, then it's considered to be a function. Okay? Now, these boxes here, you'll see these throughout the book. This is just lifted directly out of the book. And this will give terminology in bold so you can find those key words. Honestly, though, sometimes these are very dense in math speak, and usually your own definition is going to be better. Because, this has, a function of f is from set A to set B is a relation that assigns each element in x of set A into exactly one element of y in set B. Set of A is the domain or set of the inputs of the function f, and the set of B is the range or set of outputs. There's a lot there, but all it's really saying is this visualization. And I honestly like visualizations like this a little bit better. This is showing set A and B. Everything in set A is the numbers 1 through 6. That's your domain. Set B, the outputs, each one of these is going to exactly one output. Now notice, you do have a duplication. 3 and 4 both go to 15. That's actually fine. 3 can't go to both 13 and 15, though. That would make it not a function. Now graphically, we have the same type of thing. Okay, if I graph these and had x and a y-axis, we have a test to tell if something's a function or not. Anybody remember what it is? Vertical line test. This, each input value, each x value is going to an exact y value, not to two different ones. So we pass the vertical line test. So that's the way I usually reformat these in my head. Every element from A must be matched to an element of B. Well, every x value has to go to a y value. True or false?
True.
True. Every y value must be matched with an x value. False. Because you can have a function, the classic function we always see, f of x equals x squared. What's the shape look like? Parabola. Well, if I look at this extends left and right forever, correct? But the y value down here doesn't have a corresponding x. Only the y values that are greater than or equal to 0. So that's usually I do that as a quick visual when I'm thinking about whether this thing is or is not a function, whether it fulfills those requirements. 2 or more elements of A can be matched to the same element in B. True. Because if I look at this, 2 and negative 2 both go to positive 4. 2 or more elements of B can be matched to the same element in A. False. Okay. So, and this kind of just clarifies that a little bit. Again, it's a box straight out of the book. Each element in A must be matched to an element in B. Some elements in B may not be matched with any element in A. You might have extras left over. 2 or more elements in A may be matched with the same element in B, and an element in A cannot be matched with 2 different elements in B. Honestly, vertical line test is the way I always think of it. Functions are commonly represented 4 different ways. You can represent them verbally, just through descriptors. You can represent them numerically, usually ordered pairs, that kind of thing. Graphically, obviously. Algebraically is probably the one we're going to deal with the most. Okay? To determine whether or not a function is, or a relation is a function, you must decide whether each input value is matched to exactly one output. If any input value is matched to 2 or more output, the relation is not a function. So if I look at this set, 2, 3, 4, 5 for A, and B is negative 3 through 1 integers. Which set of ordered pairs represents a function from set A to B? Honestly, usually it's easier to spot the ones that are not. Does anybody see one up there that's not a function? B is not a function. Why?
Because number 2, because 2 from A is matched to 2 different B values.
Yep, 2 is going to both 0 and negative 1. So that's not going to work. Any others not work? There's one other one that doesn't work. Why would C not work?
Because -1 is paired up with 4 A value.
Now remember, X and Y, right? If I were to think of this graphically, I have 2, -1, 3, -1, 4, -1, 5, -1. Is that a function? It is, so C works. The output values can pair with multiple inputs. The inputs can't pair with multiple outputs. That's why the 2, if I graph those, 2, 0, and 2, -1, that would fail the vertical line test. That's why B doesn't work. Why would D not work? Well, it's not just that it goes like that, but it's more so, look, how many input values do I have? 3. It has to use all of them. Okay? That's why this one doesn't work, is because it has to use everything in the input. The domain, the function has to use everything in the domain. The domain in this case is 4, I only use 3, therefore not a function. Because right now, 4 is going to nothing. So that's why it doesn't work. So in this case, A and C are your answers. All right. For functions, y equals x squared, again, the classic function where y is a function of x. What is the dependent variable and the independent variable? Y is what? Y is the dependent, because it depends on what x is. It depends on the input value. The output value is your dependent. The input value, input independent. Okay? So that is a function. Is this a function? Why not? No, that doesn't directly tell you. What did you say? Yeah, you went the easy route. That's what I usually do. The vertical line test. X squared plus y squared equals 8 is a circle. Does that pass the vertical line test? No. And the problem is, just because the things are on one side of the equation, that's not enough. Because I could take this equation up here and write it as 0 is equal to x squared minus y. That's not enough to tell me whether it's a function or not. You can solve it for y, is usually what most people do, and then graph it. Then what happens here when you solve it for y, you get y is equal to plus or minus the square root. And this plus or minus is telling you that it's going to fail the vertical line test. Because it doesn't matter what's under here. Each value is going to output 2 things. Each input value is going to generate 2 values. So that's why it doesn't work. So this is not a function. Okay. Some ones like these will be fairly simple. How do I find f of 2? Plug in 2. If we plug in 2, what do you get? -2. Yeah, 10 minus 3 times 4 minus 12, -2. F of -4. Yep, -38. This is one where it's easy to screw up because when you plug it in, you might accidentally keep the negative sign. So be careful on that. The negative flips to a positive, and then the -3 times positive 16 gives you -48. 10 minus -48, -38. So be a little careful with those. What about the next one? What do I have to do for this one?
Get the x on its own.
Yeah, plug it in. You're not actually going to get the x on its own. You're going to create a function for this. You're not going to be able to solve it. Because this is f of x minus 1 is equal to 10 minus 3 times x minus 1 squared. So I don't have a number over here. I'm not going to be able to solve this for anything. It's just going to generate a new function. When I do this, though, what do I need to do first? Foil that. X minus 1. If I foil it out, I get what? Well, because the problem is I can't just square both parts independently. I also need to deal with the exponent first. Okay, so I'm going to take x minus 1 times x minus 1 first. What's x minus 1 times x minus 1? Plus 1. If you need to write it out, write it out. Okay? Then I need to distribute. Now I'm going to do the multiplication. So I have 10 minus 3x squared minus 6x plus 3. What do you mean? Yeah. You have a negative out front. Do not lose that negative. It's going to make this plus. Is it going to do anything else? Yeah, change the 3 to a minus 3. Now the people that had me last year are remembering when I make these intentional mistakes and annoy them. But thank you for just speaking up and noticing. So, last step. Combine like terms. I'm going to rewrite it in descending order, so the quadratic first, followed by the linear. And then the constant would be what? 7. So the idea is f of x minus 1 is equal to that trinomial. Okay? You'll have to do a decent amount of manipulation along those lines. You also have some that look a little strange. We didn't do much of these in FS&T. I doubt you did too much in plus with them. Anybody remember what this is called? What type of function? Starts with a P. This is a piecewise function. It's literally split into pieces. So the idea is you have two different functions that behave differently depending on where the x value is. If it's smaller than 0, you do one thing. If it's bigger than, you do another. Arithmetic-wise, it's not hard. Because if I'm doing f of, I want to find the function at negative 2, what am I going to do with the negative 2? Plug it into which? The top one. When x is less than 0, plug it in there. So I'm going to take 3 times negative 2 minus 4, which gives me negative 10. What about f of 0? Plug in the bottom one, that's going to give me 1. F of 2 gives me
7.
So those are your 3 solutions. Make sense? Okay. What about when I reverse the idea? Instead of having f of 0 or f of 2, I want f of x to be 0. Yeah. You set it equal to 0 and you solve it. Exactly. So I have for this one, yep, 21 minus 7x. X is 3. On this one, I got to do a little more work. Because when I make this equal to 0, well, it's a quadratic. I can't just solve for x. What do I need to do? No. You have the quad program you could use. Okay? You have the quadratic formula. You may remember it. It's plus or minus. Yeah. Over 2a. Negative b plus or minus square root of b squared minus 4ac all over 2a. Honestly, this one's simple enough I wouldn't do that either. I'd refer back to the worksheets you've been doing. Factor it.
Yeah,
Guys, you got a x squared out front.
Yeah, it's x plus 1 and x minus 8.
Yep, you have x and x. Multiply to get negative 8. Add up to be positive 7. So it has to be that. So your 2 solutions are what? I should put equals there. Yeah, negative 8 and positive 1. So when they're asking you to solve or find x, in other words, solve it, factor it, split it up, solve. Quad program does work. Now, one thing I want you to keep in mind, those taking AP Calc next, part of the test is no calculator. Okay, this year we will have a couple, I think we have one quiz and one test that are no calculator. Not right now, later on, but keep it in mind. It could be part of it. On the AP test, I guarantee some of it will come up there. Anyway, what about this? Set them equal to each other and solve. So 6x squared is equal to now I would move everything to the left just because I don't want to deal with a negative leading coefficient. You could move it to the right, it'll still work. But that gives me 5x squared plus 14x minus 3. And then I can factor that. I have two prime numbers, so I know exactly what numbers I need to use. So I'm going to factor it because I have 5x and x. The other two numbers have to be what? 3 and 1. They have to multiply to be 3. So that's going to be 3 and 1. Just the order is the only thing that's going to change. It's a negative, so what do I know about the signs? One positive, one negative. So if I just plug them in, so if I do negative 3 and positive 1, will that give me 14? No, because 3 times x and 5x aren't going to give me 14. So switch them. 3 and 1. That's going to give me 15x minus 1x, 14. Then what do I need to do with it? Now set each one equal to 0 and solve. So I have x equals negative 3. What's the other one? 1/5, because I have 5x is equal to 1, since it's equal to 0. And then divide. So you get 1/5 and negative 3.
Pretty good at this.
I'd hope so. It's my 10th year teaching pre-cal.
Pretty good.
Plus, I want to get to the fun problems.
Awesome.
Not quite yet, though. Domain of a function. Oops. Domain is saying when the thing works. Because the problem with a function like this, when does it not work?
When x is equal to 2 or negative 2.
When x is 2 or negative 2. In other words, when the denominator is 0. So you set the denominator equals 0 and figure out when the problem arises. What about if I have a square root? What can I not have there?
0.
I can have 0. Square root of 0 is 0. You can't have a negative number. Can't have anything smaller than 0. So your domain is everything larger than 0 under that radical. So x is greater than or equal to 0. This notation, I don't care which one you honestly do, but this one shows up in the book a lot, so I want you to understand it. This is what's called interval notation. Okay? They're saying everything in the interval between 0 and infinity works. If it's a bracket, it includes that number. So because this bracket's equivalent to or equal to. Okay? And they'll use a parenthesis if it's less than or greater than, or if they have infinity, because can you ever actually reach infinity? No, so they view a parenthesis for that. I don't care which way you answer it, but the answer in the book will often show up like this if you look it up, so make sure you at least understand it. All right. So what would the domain be in this case, or how would I find it? Sort of. I don't want to technically solve for x specifically, but I want to set up what x minus 16 has to be in relationship to 0.
Okay.
So what does it have to be? Greater than or equal to. Yep, so x is greater than or equal to 16. That's the easiest way to do that, is set up wherever the problem issue is. If it's the denominator, set it equal to 0 and solve, or not equal to 0 if you like. If it's underneath the radical, set it greater than or equal to 0 and solve. Okay. This one's a little bit strange just on the wording. Given a cone with a ratio of height to radius 3, express the volume of the cone as a function of r. Now one thing, how many variables does a function have? 2. The input and the output. The independent and the dependent, right? This equation here has 3. They want you to write one with volume and radius. So what they really want is v of r. So what's the problem? What do I want to get rid of?
H.
So I want to replace the h with either a v or an r somehow. So I need to look at the problem and see if there's a relationship between those. Ratio of height to radius. So, what does that statement imply, or what does that tell you? Say again? 3r. Now, some people can jump right to that, some not quite. The ratio of height to radius, in other words, h to r, or h over r, is 3, is equal to 3. Ratio is that fraction, right? Solve for h, you get what? 3r. So that's where that's coming from. So I'm going to replace the h with 3r. So I get 1/3 pi r squared times 3r, not h. Can I simplify that?
Yeah.
How?
Math.
Does anything cancel?
You can simplify.
Yeah.
You take out the parentheses,
Yeah, the parentheses aren't needed.
right? So you can cube,
So you can cube r because it's r squared times r.
right?
The thing is, there anything I can get rid of entirely?
Oh, the three.
The three.
Yeah, the 3 and the 1/3. 3 times 1/3 is 1. Oops, and I didn't finish that off as a 3. And then r squared times r gives you the r cubed. Okay, so under a specific case of the height being 3 times the radius, you could actually use this formula for volume. That's what that's trying to imply. Okay, a couple more.
You gonna do the hard ones?
One easy one. Well, there's only one hard one. This one. At one point during a baseball game, the ball is hit by a batter and follows the path of the equation that. Will the ball clear 20-foot fence 200 feet from home plate? This one looks really ugly, but honestly, it's probably one of the easiest ones on here.
Is 20 the height? And X is
Well, sort of. The idea is 20 is the height, because what shape is this if I graphed it?
parabola.
Parabola. Okay, it's negative out front, so it's a parabola opening down, which makes sense because you got a guy here standing at home plate, hits the ball in that pattern. It's saying 200 feet out. Well, does it clear the wall? If the wall is 20 feet tall.
So let's just solve for y at 200 feet.
Yeah,
See if it's greater than 20.
exactly. So
Oh,
plug
that was
in
an easy one.
200. So I'm going to do f of 200. Plug that in your calculator is what you get, because I'm not going to do that one. Lost your calculator?
You just lost $100.
Yeah. Well, I've had it since 8th grade, so I'm going to
So what do you get?
$75.
Anybody confirm that? Approximately 75 feet.
2 by a mile.
So since it's a word problem, you should actually be a little more descriptive on it. Again, I'm not going to be that strict on it, but at least have units and describing what's going on. So it's 75 feet high at 200 feet out. So the question was, does it clear the fence? So yes, it clears the fence. Okay. Now, the next part. Difference quotient. This is a formula we will use a few times this year. Towards the end of the year, we will use it extensively. Okay? We're just going to get used to the function manipulation of it right now. We'll do the application of it later on. So if I have f of x plus h minus f of x, they're going to give you a f of x formula to use for this, divided by h. This is the difference quotient. That just means you simplify it. Okay? I'll copy it down again on the next page. But if I look at this problem, the difference quotient for the following equation at x equals 4. So it's f of x plus h minus f of x divided by h. But in this case, x is actually what? 4. They give you x is equal to 4. So what I'm really asking here is f of 4 and f of 4 plus h. I'm going to find those two things separately, and then I'm going to plug them into the quotient. Because f of 4 is fairly simple. What do you get if you plug in 4? 17. Okay? F of 4 plus h, it takes a little more work. So I'm going to need to take 4 plus h and square it, minus 2 times 4 plus h, plus 9. What do you do first?
Foil.
Foil. That's going to give me 16 plus what?
H or 8h.
8h.
H squared.
Then distribute. You get what? Minus h.
2h.
2h. Plus 9. Lastly, combine like terms. So usually descending order just to make things easier later. You have the quadratic. The linear gives me plus 6h. And the constant gives me what?
17.
17. So now I'm going to plug both of those things into the difference quotient. I'm going to take the f of 4 plus h, subtract from it f of 4, and divide it by h.
H plus 6.
Yep. 17s go away first. And then since everything's divided by h, you can take an h out of every single term. You're left with h plus 6. What do I need to add to that, though?
Easy. That's what I like.
Yeah, h can't equal 0 because the original thing was a quotient. And this thing does not exist if h is equal to 0. Even after the simplification, because the original had that extra piece in it. Questions on any of it? Yes?
So what is a difference quotient?
It's relation. I mean, we'll do a lot of the application of it later, but the idea is in calculus it allows you to find out information you need from a function. It describes what's going on. It's actually a version of slope,
Okay.
but it's slope for instead of just like a straight